Welcome to this immersive journey into the wonders of the Moon. Often gazed at from Earth with curiosity and awe, the Moon is more than a celestial body. It's a key to understanding our own planet and the broader universe. In this presentation, we'll explore its features, its influence on Earth, and its place in science, history, and culture. Let's begin our lunar mission. By the end of this session, you will have a comprehensive understanding of the Moon's structure, surface, and behavior. You'll learn how it shapes life on Earth, discover its unique geological history, and trace the steps humanity has taken, and will continue to take, in exploring this incredible satellite. The Moon is Earth's only natural satellite and has captivated human imagination for millennia. It plays a crucial role in our planetary system. Not only does it illuminate our night skies, but it also drives the ocean tides through its gravitational pull. Additionally, it helps stabilize Earth's axial tilt, contributing to a relatively stable climate over geological timescales. The Moon completes one orbit around Earth every 27.3 days, a cycle that has inspired calendars and rituals throughout history. Scientists believe the Moon was formed around 4.5 billion years ago, possibly from the debris of a massive collision between Earth and a Mars-sized body named Theia. The Moon, though ever present in our skies, remains a world vastly different from Earth. With a diameter of 3,474 kilometers, or about 2,159 miles, it's roughly one-quarter the size of our planet. Despite its small stature, it plays a major role in Earth's natural systems. On average, the Moon is located about 384,400 kilometers, or 238,855 miles, away from Earth. That's approximately 30 Earth diameters, a distance so vast that all the planets of the solar system could fit between the Earth and Moon. Gravity on the Moon is only about 1/6 of what we experience on Earth. This means a person who weighs 60 kilograms on Earth would weigh just 10 kilograms on the Moon, a fact that allowed astronauts to take those iconic, bounding steps during lunar missions. Beneath the Moon's surface lies a layered internal structure, a thin crust, a mantle, and a small core. The surface itself is covered in a blanket of fine dust and broken rock known as regolith, formed over billions of years from meteor impacts. The Moon also faces extreme temperature changes. With no atmosphere to trap heat, temperatures swing dramatically, plunging to a frigid -173 degrees Celsius during lunar night, and soaring to 127 degrees Celsius in sunlight. This harsh environment makes lunar exploration both scientifically thrilling and technologically challenging. The Moon's journey around Earth is far from simple. Its orbital path is not a perfect circle, but an elliptical orbit, slightly stretched out, with an eccentricity of 0.0549. This means that at times the Moon is closer to Earth, known as perigee, and at other times, farther away, at apogee. The time it takes for the Moon to complete one full orbit around Earth, measured against the distant stars, is called a sidereal month, lasting about 27.3 days. But when we measure from one new moon to the next, accounting for Earth's own movement around the Sun, we get the synodic month, which is slightly longer at 29.5 days. One of the most fascinating features of the Moon's motion is tidal locking. Because of gravitational interactions over millions of years, the Moon's rotation has slowed to perfectly match its orbital period. As a result, the same side of the Moon always faces the Earth. The far side, often called the dark side, remained hidden to humanity until the advent of space exploration. Together, these orbital mechanics shape the Moon's appearance, affect Earth's tides, and contribute to the rhythm of time as we know it. The Moon's surface is shaped by billions of years of cosmic activity, divided into two main regions, the Maria and the highlands. Maria are dark, flat plains formed by ancient volcanic eruptions, covering about 17% of the Moon's surface. Early astronomers mistook them for seas. Famous examples include Mare Imbrium, Mare Serenitatis, and Mare Tranquillitatis, the Apollo 11 landing site. The highlands, making up 83% of the surface, are lighter, older, and more rugged, composed mainly of anorthosite rock. The surface is also dotted with countless impact craters, like Tycho, Copernicus, and Clavius, each telling a story of the Moon's violent past. The Moon goes through 8 distinct phases during its monthly journey around Earth, caused by the changing angles of sunlight that illuminate its surface. It begins with the new Moon, where the Moon is positioned between the Earth and Sun, making it nearly invisible. As it orbits, we see more of the illuminated surface, from the waxing crescent to the first quarter, and then the waxing gibbous. The cycle peaks with the full moon, a brilliant display of the fully lit lunar surface. Then, the illumination decreases through the waning gibbous, last quarter, and finally the waning crescent before beginning anew. These phases are essential not only for calendars but also for agriculture, religious rituals, and cultural storytelling around the world. The Moon doesn't just light up our night sky, it plays a powerful and essential role in shaping life on Earth. Its gravitational pull is the driving force behind tides, moving vast bodies of water and creating coastal ecosystems vital for marine life and human activities. It also helps stabilize Earth's axial tilt, preventing extreme shifts in climate. Without the Moon, Earth's tilt could wobble chaotically, making stable seasons, and life as we know it, far less predictable. Through a process called tidal friction, the Moon gradually slows Earth's rotation, subtly lengthening our days over millions of years. Beyond science, the Moon holds deep cultural significance. It has guided agricultural cycles, inspired calendars, myths, religions, and countless works of art across civilizations. Its influence touches both the physical and the spiritual world. Human exploration of the Moon marks one of the greatest achievements in science and engineering. It all began with the historic Apollo 11 mission in July 1969, when Neil Armstrong and Buzz Aldrin became the first humans to set foot on the lunar surface. This was followed by a series of Apollo missions, each expanding our understanding of the Moon's geology and environment. From Apollo 12 to Apollo 17, astronauts conducted experiments, collected samples, and even drove a lunar rover across the surface. The final Apollo mission, Apollo 17, took place in December 1972, with Eugene Cernan and Harrison Schmitt, the last humans to walk on the Moon. These missions laid the groundwork for future exploration, including potential moon bases and missions to Mars. Humanity is preparing to return to the Moon, not just to visit, but to stay. At the heart of this effort is NASA's Artemis program, which aims to land the first woman and the next man on the lunar surface, marking a new era in space exploration. Supporting this vision is the Lunar Gateway, a planned space station in lunar orbit, and future surface habitats designed to enable a sustainable human presence on the Moon. Key to long-term missions is ISRU, or in situ resource utilization, using local materials like ice for water and regolith for construction, reducing the need to transport everything from Earth. This ambitious future is built on international collaboration, with agencies like NASA, ESA, ISRO, CNSA, and private companies working together to turn the Moon into a gateway to deeper space, and eventually, Mars. The Moon is far more than just a distant rock in the night sky. It's a scientific marvel, a cultural icon, and a historical witness to humanity's progress. By exploring and understanding the Moon, we not only uncover the secrets of our own planet, we take the first steps toward understanding our place in the universe. Thank you for watching. Keep looking up. The journey has only just begun.